Here are solutions to homework set number 2 for ECE 111. This homework set looks at using Matlab to solve one equation for one unknown. This is similar to what you do in Math 103 Algebra 1. For example, the first problem, suppose I have y equals x plus cosine x. Solve for x given that y is minus 0.5. Now given x, solving for y is easy. The hard problem is given y, solve for x. Using algebra, you may or may not be able to find the answer. With Matlab, you can find an answer using numerical methods. So one approach is to use graphical methods. What I'll do is I'll just graph x versus y. In Matlab, x goes from minus 2 to plus 2, steps of 0.01. Y is just x plus cosine x. What I'm doing is I'm guessing the answer. I'm guessing the answer somewhere between minus 2 and plus 2. Here's y. Plot x versus y. Then here's what the graph looks like. I can now read off the graph. When y is plus 0.5, here's x. When y is minus 0.5, there's x. So that's one way to do it. Graphical solutions. There's two answers. Well, one for each one. Problem 2 is, okay, suppose I want to get more accuracy. Off the graph, it's kind of hard to read that to 7 decimal places. Can I use numerical methods to get the answer? And here's where I'll use numerical methods, or Newton's method. What I'll first do is come up with a function in Matlab that returns the error between the desired output and what it should be. So if y should be minus 0.5, the error is the difference between y and minus 0.5. So y minus 0.5 is y plus 0.5. Call that problem 1. What I'll then do is use Newton's method, iterate. I'll take a guess, I think the answer is 0, and keep guessing until the answer is 0. What Newton's method does is, in this case, if I redefine this to be 0, I want to find out when is y is minus 0.5 or shift everything up by 0.5. This is the 0 crossing. Take a guess. I suppose let's say my initial guess is 0.2. I'll draw the tangent to the curve, see what crosses the 0 line. That's my next guess. Now draw the tangent and pretty quickly converges. So that's what this code does. I'll take a guess. My first guess is 0. I'll find out how much is the error at that point. I will then perturb x by 0.01, find the error again, and now do interpolate. Find where the 0 crossing is, and here what that is, kind of showing you, suppose my first guess is 0, right here. This is 0 plus 0.01, draw the tangent line. That's my next guess. This point is the first guess, right here, 0, times the error, the bigger the error, the further I move, times the slope, times dx over dy. So this is the equation for interpolating, trying to find the 0 crossing. There's the previous point, my previous guess. Adjust it by how large the error is times the slope, actually the inverse of the slope. That's my next guess. So here is problem 1. I'm going to guess x. Here's a function in Matlab. It calculates y1. I want it to be minus 0.5. Take the difference in the two. This part is just for fun. It's going to draw a curve showing what the function looks like, where my guess is. And then Newton's method says I'm going to take my guess. So my first guess is 0. Start iterating, seeing what the next guesses are. So here's my first guess. Let's slow that down. 2 seconds between guesses. First guess, second guess, third guess, fourth guess. That's Newton's method. I have to give it a guess that's reasonably close. If I'm too far off, like let's suppose my first guess is 9,000, it may not converge. It helps to know the answer to find the answer. If I start out fairly close, it will converge. This pause of 2 really slows it down, but you can kind of see what's happening. If I look over at the command window, the command window is showing what's happening. So this is showing my guess number, what x is, here's the error. And pretty quickly the error is driven to 0. Newton's method converges really fast. Best to find the solution at minus 0.5. To get the solution at plus 0.5, I simply go over here, P1. I now say I want the answer to be plus 0.5. If we go back to Newton's method, let's draw the graph so you can see what's going on. I now want to be plus 0.5, first guess, second guess, third guess. And pretty quickly, it's nailed the answer. Seventh guess. Basically, after 4 iterations, I nailed it. The answer is x is minus 0.4151. This is one of the beauties of Newton's method. Even if you can't solve by hand, I can find the answer using numerical methods. Part of what makes Matlab so powerful. Problem 3. Okay, let's change the problem. I've got 2 equations, 2 unknowns. Find x. One way to do that is set the 2 equal to each other, and I have 1 equation, 1 unknown, or bring it left. Function equals 0. Repeat. Find all answers. So here what I'm going to do is first graph it. I'm going to have x going from minus 4 to plus 4, guessing that's the answer somewhere between that range. First function is cosine 2x. Second function is x minus 2 times x plus 1. Needing the dot notation to tell Matlab don't treat that like a matrix multiply. That's element by element multiply. Plot. And here's the graph. That tells me that there are 2 answers. One is close to minus 1, the other one is close to 1.5. Problem 4. Repeat using numerical methods. So let's go back to Matlab. If we go on to problem 3, I'm going to guess x. Here's the first function. There's the second function. I want to know when is the difference 0. So let's call the error. Drive the error to 0. Function equals 0. Excuse me. Just for fun, let's plot x versus y1, x versus y2. I'm going to call that z1, z2, just so I don't overwrite these variables, and then plot it. Repeat using Newton's method. So this stays the same, except instead of driving problem 1 to 0, I want to drive problem 3 to 0. If I try that, here's my 2 functions. I'm trying to find where the 2 match up. Now it helps to know what the answer is. I actually have 2 different solutions. My initial guess tells me which one I converge to. I've got a solution close to minus 1. So I made my initial guess close to that, say minus 1. Here's the first guess, second guess, third guess. Or in the command window, I can see it converged to minus 0.9132. So let's put this over here. If I make my initial guess close to this one, that's about 1.5. Starting from here, it will tend to converge to the closest solution. It converges to 1.6, and actually the answer is 1.6202. Again, this is actually a really hard problem to solve using algebra. Not a problem in Matlab. If I can get the functions into Matlab and give it a good initial guess, it can converge and find the solution. Problem 5. Let's change the problem to be temperature sensor. Given temperature, I can find resistance. Suppose instead I know resistance. What's the temperature? Well, once again, what I'll do is create a function in Matlab. I'm going to guess the temperature, calculate the resistance. I want the resistance to be 12,000 ohms. Take the difference in the two, drive the error to 0. And just for fun, let's plot it. This plots the two, tries to drive it to 0, kind of showing what Newton's method does. So that's problem 5. In Newton's method, all I do is change this one line of code, okay, 2 lines of code. This is the function I want to drive to 0. So if I say my first guess is about 10 degrees Celsius. So now if we use Newton's method, if my first guess is 10 degrees Celsius right here, it'll draw the tangent. That's my next guess. Keep on drawing the tangent, find the 0 crossings. And pretty quickly, I drive the error to 0. There's the main window. So there's the error, there's the temperature. That tells me that at, where am I? 12,000 ohms, the temperature is 7.1722. If I want to be 6,000 ohms, change that one line of code, go back to Newton's method. Here's 6,000 ohms. This point is my first guess, second guess, third guess, fourth guess. Here's the error on the right. That point is 21.1027 degrees Celsius. That's 6,000 ohms. Again, even if I can't solve the equation by hand, I can use numerical methods and iterate and find out what the answer is. Last problem. Oh, the number of iterations, I just look at the error. How long does it take the error to get within 1? So here's 4, 5, 6. It's converging really fast. The last problem is, suppose instead I have a function of a function. Temperature tells me resistance, resistance tells me voltage. At what temperature do I get 4 volts? What temperature do I get 3 volts? Again, that's really the same problem. I'll just take the previous problem. Given temperature, calculate resistance. Given resistance, find voltage. When is the voltage equal to 4? Take the difference in the two, drive the error to 0. And this down here isn't really needed. It's just kind of for fun plotting. It plots the answers. What that looks like is if I save that, go back to Newton's method, and I want to drive P7 to 0. So my first guess, draw the tangent, second guess, third guess, fourth guess. 4 volts corresponds to 15.1562 degrees Celsius. If instead I want the answer to be 3 volts, I'll go back over here. There's my voltage. I want the answer to be 3. When is the difference 0? Save that. Go back to Newton's method. First guess, second guess, third guess. Basically nailed it. 3 volts is 36.4909 degrees Celsius. That's Newton's method. A couple things to note. Matlab is a really powerful program. Newton's method is a very powerful algorithm. Newton's method is used all the time. Anytime I want to solve a function, if I can set it up as function equals 0, I can use Newton's method. You kind of see here, Newton's method was the same, just change the function that I want to drive to 0. It helps to have a good initial guess. If your guess is too far off, Newton's method sometimes does, sometimes doesn't converge. So it kind of helps to know what the answer should look like. That's kind of where you use your engineering judgment, knowing what I know, what should the answer be close to. Take that as my first guess, and then Newton's method will zero in on it. And even if I can't solve the problem by hand, Newton's method can usually grind out the answer. Kind of a sidelight, this is part of the reason on homeworks and tests you need to show your work. If you're taking algebra or any other class and they ask you to solve a problem, I can usually throw that in Matlab and get an answer. The fact that Matlab can solve it doesn't mean that I know how to do the algebra. That's kind of why you have to show your work. What Matlab is good for is it'll tell me that if I solve this equation by hand, I should get the answer 36.4909. This is a good way to check your answer. You don't have to use Chegg, you don't have to use ChatGPT. Matlab will tell you what the answer is. and it's actually useful. I know what the algorithm's doing. I know how it works. Basically, I can kind of trust this answer. When you throw something in ChatGPT, it gives a number. Might be right, might not. You don't really know. You kind of need to understand your own work. This is a good way to check your answer to see if your calculations match up with what numerical methods tell you. That's homework set number 2 for ECE 111.